Very good one. Today we are going to discuss Simpson one-third rule to find the numerical integration or to solve the numerical integration. So to find the integration by using Simpson one-third rule, so this is the relation for Simpson one-third rule. Okay, so by using this relation, we can find the integration. So first we'll discuss its analytical procedure. So let's discuss or this problem. Okay. So here integration is given 0 to 0.8 and this function is given. So by using Simpson one-third rule, we have to find its area. Okay. So here number of strips are taken as a 8. So first we will write all the given data. So function. So f of x is given is log of x plus 1 plus sine of 2x. Here up lower limit is given as a 0, upper limit is given as a 0.8. And here total number of strips are 8. So from this you can find the step size. So step size you can calculate it as a xn minus x0 upon number of strips. So here step size is a 0.1. So we can find the value of this function, okay, from the lower limit to the upper limit. Okay. So start with the lower limit. So when x is equal to 0, that time the value of function y is also 0. Okay. Now we are going to find the value of this function from lower limit to the upper limit. Okay, and here step size is a 0.1. So from first iteration to the last iteration, so we are increasing this step size. Okay, so for first iteration we have the step size 0, then next iteration we will add this step size, so it becomes 0.1, then next iteration it becomes 0.2, next iteration it is 0.3, so on. Okay, so in the next iteration x is now 0.1, and for this value of x we can find the value of function by putting this x is equal to 0.1 in the above function. So you will get the value of function as a y1, and which is 0.2939. Then again in the further iteration this x value becomes 0.2. Okay, and correspondingly you will get the value of function, and that value is y2 is equal to 0.5717. Then next iteration you will get x3 is equal to 0.3. Then from that you can calculate y3, so on. So up to the last limit, okay, x8 is equal to 0.8, you will get the value of function as a 1.5878. Okay. So as per Simpson rule, we have the relation. We can calculate the integration by taking the relation as a h by 3 into y0 plus yn. Okay, so here what is relation for Simpson rule? Y0 plus yn. So y0 means your first reading and yn means last reading. Okay, so in this case first reading is a y0 and last reading is a y8. So we will consider the value of function for first and last reading. Then 4. Okay, 4 into odd terms of y. So odd terms of y, so we can say that here odd terms of y means here you will get the values in terms of y1, y3, y5. Okay, and then y7, then plus 2 into even terms of y. So even terms of y means we can say that it becomes y2, then y4, okay, and then y6. Okay, so here we will substitute this value 4 into y1 value. So y1, to check this, so from here you will get y1, then plus y3 plus y5 plus y7. Okay, then 2 into odd terms of y. So sorry, 2 into odd terms of even. Yeah, so 2 into y2 plus y4 plus y6. So just substitute all those readings and you will get the value of function. So here h is step size is 0.1. So you will get the area under the curve as a 0.7725. So this is the analytical approach for this Simpson one-third rule. Now we will discuss the code for this Simpson one-third rule. So suppose this is the code for Simpson one-third rule. Okay, I'll explain this code. So I have copied that code and pasted here in the page. So here the first line, okay. So whatever the procedure we have implemented analytical procedure. So that procedure we are going to write in the form of code. So here in the code, so here first term is the okay. So we need to enter the function. So to enter the function in MATLAB there is a command as a inline. So for function we are taking suppose variable as a y. Okay. So y is denoting the function, and to input the function we are using inline command, and here the function is suppose e raised to x. Then give the lower limit and upper limit of the integration. So let us consider x0 is the lower limit of the integration and xn is the upper limit of the integration. Then as per the problem statement, write the number of strips. Okay, so enter the number of strips. So for that we have taken n variable, and then you can calculate the step size. Okay, so for that we have the relation xn minus x0 divided by n. Now after that, there are again two variables are considered constant variable as a1 and a2. Okay, and its value initially is taken as a 0 0. The purpose of this constant is to get the even term as well as y term, because in this relation we have the odd terms of y and we have the even terms of y. So to get all the odd terms and to get all the even terms we have taken this variable. So a2 is equal to 0. So this a2 variable represents all the even terms of y. Okay, so we can say that it is y2, y4, y6, and this a1 represents all the odd terms of y as a y1, y3, y5, y7. Okay. Now here we are using the loop. Okay. So for I is equal to 1 as to n minus 1. So the here I is equal to 1 as to n minus 1 means we need to start from the first value of the function to the n minus 1. N minus 1 means second last value. Okay, because why we are using this from I is equal to 1 as to n minus 1, because here already we have taken first reading as a y0, okay, and last reading as a y1 in the formula. Okay, so now we need to find the remaining terms in between this y0 and yn. So in the particular problem we have total 8 readings. So in between y0 and y8 we have the reading as the y1, y2, y3, y4, y5, y6, y7. So to get the values of this y1 to y7, okay, we are defining this route. Okay, so for that now we are again writing the logic to get all the odd term and to get all the even term. So here under this loop the logic is written if mod of I comma 2 is equal to 0. Okay, that time we are writing this a2 value as a2 plus y of x0 plus ih. So the meaning of this logic is mod of I comma 2. Okay, so mod of I comma 2 is the meaning means when we are defining any number by 2, okay, that time suppose the remainder is 0, so we can consider it as a even number. Okay, when mod of I comma 2, mod is the function used in the MATLAB to check whether your remainder is 0. Okay, or it is just used to check the remainder. So suppose if your value is a suppose 4 and you are dividing it by 2, so you will get the answer as a 2. Okay, so your answer is 2. Okay, so in that case there is a remainder 0. Okay, so in this case remainder is 0, so we can say that the 4 is your even number. Okay, so same logic is implemented here. If mod of I comma 2 is equal to 0 means when the value of I, okay, is divided by 2, it is completely divisible by 2, and that time remainder is 0, we can consider it is a even term. Okay, or else in we directly if it is not divided by 2, so we can say that it is a odd term. So suppose start with this looping. So initially I is equal to 1. Okay, so when we are defining dividing this I by 2, okay, so I is initially 1, so when we are dividing 1 by 2, so you will get the answer as a 0.5. Okay, so in that case remainder is not 0, so we can say that it is the odd term. Okay, and so this logic is failed for I is equal to 1. So the loop will goes to the else part, and in else part we are getting the a1 value as the a1 plus y of x0 plus I. So in this case, x0 is a 0, I is your 1, and h is step size in that particular problem is a 0.1. So you will get 0 plus 0.1. So 0 plus 0.1 means you are getting the x1 value as a 0.1. Okay, and for that, what is the value of function is y1. Okay, and that y1 means your odd term. Okay. Same way, now loop will continue when I is equal to 2. So now check whether 2 is divided by the 2. So in that case, I is equal to 2. So 2 is divided by 2. So we can say that in that case, remainder is 0. So now I is divisible by 2 means we can say that I is now even term. Okay, and when we are defining even term, so for that we have taken this coefficient as a2. Okay, and we can say that this logic y of x0 plus I into x. So in this case, x0 is a 0. Look at this example, x0 is a 0 plus, so plus I into it. Now in this case I is 2. Okay, so in this case I is 2. So 2 times, okay, we can say that 2 times h. Okay, 2 times h means 2 into 0.1. Okay, so you will get directly 0.2 value. Okay, so in that case 0.2 value belongs to the x2, and for that value of the function is the y2. So here directly we'll get the y2 terms. Okay, so even terms of y. Now again loop will continue when I is equal to 3. So now check whether it is divided by 2. So when 3 is divided by 2, in that case your answer is 1.5. Okay, remainder is not 0. So in that case we can say that it is a uh, it is a odd term. So this loop will be cancelled, and it goes to the else part, and in else part we will get the value of y3. Again the loop will continue for I is equal to 4. Now I is equal to 4 means it is even term, so you will get directly y4 value. Then it will goes to the I is equal to 5. So I5, now it is a odd term, so it will go to the else part. So in that case you will get the y5, so on. Then again y6 and y7. Okay, no need to calculate y8 because this loop will prompt to 1 to 7 only. Now, after the execution of this loop, we are taking one more variable as a a3. Okay, and this a3 just represent the addition of this y0 and yn. Okay, so the purpose of this a3 is to get this addition of y0 plus yn. Okay, now we will write this formula in the form of code. Okay, so this formula we are writing here. So area is equal to h by 3. Okay, then a3 means y0 plus yn plus, here it should be 2 into a2. A2 means all the even terms. Okay, so it is nothing but all the even terms. So we will write this all even terms 2 into a2. Then 4 into all odd terms. For odd, we have taken a1 variable. So we will write 4 into a1. So directly you will get the integration value. Okay, so this area is your required answer, and you can print this area. So this is the MATLAB code. Now I'll show you how to execute this code. So just you can write this code in WordPad or Notepad, then copy the code. You can execute the same code in Octave Online Simulator, okay, which is available on Google. So here you can make a file. So define the Simpson 1 by 3 rule. Then paste your code, copy it. Okay, and here the problem statement is given. Okay, we'll see here. We need to find the integration of exponential of x means we need to find the integration of x, and here lower limit are 0, upper limit is the 4, and number of strips are 4. Okay, so here is the problem statement. Okay, so it is, we need to find the integration of e raised to x dx. Okay, here lower limit is a 0, upper limit is a 4. Okay, and number of strips we are taking as a 4. Okay, and for that we will write the code. So here exponential of x. Okay, so I execute the code. So lower limit is a 0, upper limit is a 4, number of strips are 4. So it gives the area. Okay, integration value is a 53.86386. Okay, so this is the output files in the MATLAB code. Then for that solver is there. Okay, so in the solver, just you need to remember two line syntax. Okay, so to find the integration, so by default syntax is this. Okay, so here I'll write So first thing, we need to write at the rate. Okay, then we need to write the variable used in the function. So our function is the e raised to x. Okay, so in that case, variable is used as the x to define this variable in round bracket, and in round bracket itself you need to write the function. So in this case, function is the exponential of x, means the function is e raised to x. Okay, so write that function here. After that, in the next line, okay, the next line we need to type. Okay, so this q is the just any variable. Okay, instead of that you can take any name, and after that you need to use the command as a quad qad. Then what is the variable used for function? We have taken f, so write that variable of the function, and after that write the lower limit and upper limit of the integration. So comma, lower limit is 0, upper limit is a 4. Okay, and save this code. Okay, and just execute it. So you will get the area as a 53.59. Okay, so just compare the result by the program. Okay, and these are the result by the solver, so both the results are same. So we have validated the answer by using this analytical approach, as well as by using this MATLAB code and by using this solver. There is a one more method to find the numerical integration. So that method is a Simpson 3 by 8. Okay, it is quite similar as that of Simpson one third method. Okay. So Simpson 3 by 8 method. Okay. So for Simpson 3 by 8 method, there is a relation. I'll just show you. So this is the relation for Simpson 3 by 8 rule. Okay, so it is quite similar as that of your Simpson one third rule. So here instead of h by 3, you can take 3h by 8. Okay, so slight change will be there in the function in the program. So you can write this area of as a, okay. So 3h by 8 into y0 yn. Okay, so y0 yn logic will remain same, but here you need to take 2 into term of multiple of 3. Okay, so y terms we need to select y terms which are multiple of 3. So when we say that it is a y3, okay, then next term is a y6, then it is next term is a y9, okay, y12. So these are the multiple of 3, and whatever the remaining terms are there, okay, so that can be multiplied by using 3. So remaining terms may be y1, y2, y4, y5, y6. Okay, so suppose here problem is given. So we need to find the integration by using Simpson 3 by 8 rule, and n is equal to 6. So upper limit is the 1, lower limit is a upper limit is a 4, and lower limit is a 1. Number of strips are 6. So from that we can calculate step size h is equal to 0.5. So from lower limit to the upper limit, we need to find the value of this function. Okay, so here lower limit is x0, so for that corresponding value of y is y0. Upper limit is a xn, so in this case our number of strips are 6, so x6 is equal to, we'll get the y6. Okay, and in between these 1 and 4 we are going to find the value of this integration. So in the first iteration we will get x0 is equal to, we have x0 is equal to 1, and for that we are getting the value of function y is equal to 3. In the next iteration, we are incrementing the value of x by using step size. So x0 plus h, so you will get 1.5. Okay, and when x is equal to 1.5, you will get the value of function y as a 5. Then in the next iteration, you are again increasing the step size by 2h. So you will get x2 is equal to 2, and for that value of function y2 is equal to 7. Okay, so on up to 6 strip. Okay, you can find the value of this function. Now put all the values in this relation. This is the Simpson relation, 3h by 8. Okay, so 3 into step size into divided by 8. Then first term plus last term. So first term is a y0 and last term is a yn. Then plus 2 into the terms of y which are multiple of 3. So multiple of 3, so we can take the yes y3. Okay, and y6, but y6 is the last term, so already we have written here y6, so there is only one term as a y3, so 2 into y3. Okay, and all the remaining terms are, so remaining terms are 3 into y1, y2, y4, y5, and write this in this relation. So you will get the area under the curve, okay, or integration value as a 27. So you can so this code is the MATLAB code for this Simpson 3 by 8 method. Okay, so MATLAB code for Simpson 3 by 8 method is quite similar as that of your Simpson one-third rule. Okay, so here code is nearly same. So you need to enter the inline function. Okay, then you need to enter the input. You need to input the lower limit, also upper limit. Then n is equal to enter the number of steps. Then find the step size. Again here we need to find the terms which are the multiple of 3 and then remaining terms of y. Okay, so we are taking the variable, so here we will consider the variable. Okay, I'm writing in the what are the changes here itself, so we can say that a1, so a1 is represent your all remaining terms. Okay, remaining term. Okay, and in this case a2 define the terms of y multiple by 3. Okay, it in short y3, y6, y9. Then logic is again same, we need to find the in between the value, because here the first value is y0 and last value is the yn. So in between, so in our particular case first value is the y0, okay, and last value is the y6. So in between this y0 and y6 we need to find, so from y1 to y5. So for that you can write the for I is equal to 1 is to n minus 1. So from y1 to the y5, and here we are making the slight change in the logic. Okay, so what is I'll make the changes here. So here instead of 2, I'll just crop it. So here you can write I comma 3. Okay, so if mod of I comma 3, so meaning of this is when your I is divided by 3. Okay, when I value is completely divided by 3, so that time we can say that this value of y is divisible by 3, or if it is not divisible by 3, so it goes to the y1. Okay, so this a2 stores all the value which are divisible by 3, and this a1 store all the remaining value. Okay, so this is the logic will remain same, and here also a3 will take as a y which contains the value of y0 and yn, and the formula will change. Okay, so this a3 will be changed here. Okay, so this here in a3, so we will write area. So we'll write area is equal to, so I'll directly copy this code. Okay, so it gives you the relation area is equal to 3h by 8. Okay, then a3, so a3 contain yes y0 yn. Okay, so this a3 contain y0 plus yn plus here 2 times 2 into multiple of 3. So multiple of 3 means the number or the value of function which is divided by 3 is contained in the coefficient a2. So we will write 2 times a2. plus 3 into remaining terms. So remaining terms are stored in A1. So we will write here 3 into remaining terms. So when you execute it, you will get the final area. Okay. So you can execute this code. Okay. So it is asking you the lower limit. Okay. Here you can make changes. It is lower limit. Okay. And here it is upper limit because we have taken upper limit as xn. Okay. So here it is asking the lower limit. So lower limit is 0. Okay, because you can check here problem in the problem statement. Lower limit is a 1 and upper limit is a 4. Okay. So we can enter lower limit is a 1, upper limit is a 4. Then number of strips are in this case 6. Okay, so you can enter here 6 number of strips as a 6. Okay, so you will get the area as a 27. Okay, you can cross check these answers with your analytical approach. So here area is at 27. Okay, see here. So your answer of MATLAB code is matches with your analytical approach. Okay. So same way for that also you can write the solver. Okay, the solver remains same as the one third Simpson one third. Okay, you need to enter the function. Okay, so first consider the variable to define the function, then type at the rate, and your function is now in terms of x variable. So in bracket you can write x, then write your function 4x minus 1, then take one more variable to get the value of integration, then type the command as a quad, then enter the coefficient of the function. Okay, enter the variable of the function which is f, then enter the lower limit and upper limit. So lower limit is a 1, upper limit is a 4. Okay, and just execute the code, you will get the answer. Okay, so here I'll show you. Then in the next line, save it and you will get the answer. Okay, so here q is equal to 27. So your answer is matches with your answer by the solver, nearly matches with your area. Okay, so this is your solver. So this is your Simpson one third method and 3 by 8 method.